F block elements. Elements in which the last electron enters in F orbitals are called F block elements. F block elements present in the bottom part of periodic table. And this block mainly consists of two periods. And the first period is called lanthanides. The elements of this period fill 4 orbitals. Okay, that is 4 orbitals are filled in this series. Second series is actinides. Second series. Here 5 of orbitals of elements are filled. The last orbital is 5f and the last electrons are entered into the 5 of orbitals. Actinides elements. The majority of actinide elements are radioactive. Actinides are radioactive. For example, uranium, U, neptunium, plutonium, etc. belong to this series. So most of the radioactive elements used in nuclear reactors belong to actinides. Like D block elements, F block elements also forms colored compounds. F block elements also form colored compounds. And majority of F block elements are metals, so their melting point and boiling points are high. Clear? Next topic is how to predict group, period and block of a given element from electronic configuration. Let's see some examples. Number 1, sodium. What is symbol of sodium? 11. Can you tell the electronic configuration? 1s2, 2s2, 2p6, then 3s1 is very important. Okay, 1s2, 2s2, 2p6, 3s1. Why 3s1 is important? Because this one is K shell, L and is a part of M shell. So valence shell is important. Okay, so 3s1 is belong to valence shell. So valence shell is important for finding group, period and block. Now see where the last electron enters. The last electron enter in s orbital, so the block is s block. Period can find out from the configuration. How we can find out period? Just look at here, 3s1. Here 3. That 3 is equal to period. So period is always equal to valence shell, or this number is also called principal quantum number. This number is called a principal quantum number. Okay, so how to find out period? From the shell number. Which shell? The last shell number, valence shell number 3. And how to find out group? Group is very simple. This number 1. Number of electrons in the valence shell is equal to group number. So group of sodium is 1. So just check the periodic table and check it correct or not. Sodium belong to group 1, correct. Belong to S block, correct. Which period? Third period. So it's exactly correct because hydrogen. Okay. Next is lithium, then sodium. Okay. So here beryllium, magnesium. Here potassium. See, 1, 2, third period. S block, S block. Which group? First group. So like this you can find out group, period and block from electronic configuration. Now we can try one element from P block. Okay. Chlorine 17. What is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p5. So K shell, L shell, then it's part of M shell. So which shell is important? Last shell. So take only 3s2, 3p5. Okay, this complete shell is important, not only 3p5, 3s2, 3p5. And previous example 3x1, there was no 3p, so we took only 3s, but here 3s and 3p both are present in the valence shell, so take both together. Now which block? Tell block, last electron entering P block. Then group. What is group? Number of electrons in the valence shell. Valence shell, how many electrons? 2 plus 5, 7. Here, very important point, it is only applicable for P block. If element is from P block, always add 10 along with the number of electron. Then what you will get? 17. Clear? If element from P block, add 10. S block, T block, F block, no need to add 10. Directly you can write number of electrons, valence electrons. Okay. Now period. How to find out period? You remember period? How to find out period? Period is from the principal quantum number or cell number. What is cell number here? 3. Belong to M. Third shell, so period is 3. So what is the position of chlorine in the periodic table? Chlorine belong to third period and 17th group, then belong to P block. Okay, check it, periodic table, whether it correct or not. Magnesium, atomic number is 12, electronic configuration 1s2, 2s2, 2p6, 3s2. 1s2 K shell, 2s2, 2p6L, 3s2, no 3p, so 3s2 is M shell. So which shell is important? Last shell. Now block is easy to find out. What is a block? S block. Then period also easy. Where the period? Here, shell number. Okay, shell number or principal quantum number. Okay, period 3. Group, element is from S block. Okay, so don't add 10. Okay, and what is the group number here? Number of electron in the valence shell. How many electron? 2. And here you don't add 10. 10 is adding only for P block element. So what is group number? 2. So magnesium belongs to second group, third period and S block. Nitrogen, atomic number 7, electronic configuration 1s2, 2s2, 2p3. 1s2 is K shell, 2s2, 2p3 L shell. So valence shell is L shell, 2s2, 2p3. Block is which block? Last electron entering P, so block is P. Period, shell number KL, second, so period is 2. Group number, group is equal to number of electrons in the valence shell, 2 plus 3, 5. And element belong to P block, so add 10, so 15. So nitrogen belong to 15th group, second period and P block. And this is the way to find out group, period and block of a given element from electronic configuration. Find block, group number and period of following elements. Potassium 19, fluorine atomic number 9, carbon 6 and argon 18. Okay, all the best. Thank you.